Good evening, ladies and gentlemen, and welcome to this Saturday evening live session. And let me just quickly first stop this. Okay, so I hope my voice is visible. I hope my voice is audible. Are you settled? Yeah, very good. Thank you very much. All right. So today we are going to discuss very important lean concepts, which is debottlenecking and line balancing. Now this is applicable in all the industry. It is not only manufacturing or only automotive sector. No, it is applicable absolutely in a bank. It is applicable. It is applicable in a in a service center, in a hospital, or it is applicable in a BPO. So anywhere wherever you have processes, you can debottleneck that process and increase the productivity, increase the capacity of that process. That is something what lean does, and that is what we are going to discuss today. And the objective is, you can, we'll take very simple examples, practical examples, so that you can easily connect with the concepts. And once you connect with the concept, the objective is you can actually implement it in the real life scenarios. Okay, so let's begin our journey. Let me share my screen with the PPT. First, let's understand some of the lean jargons. Jargons are nothing but the jargons are nothing but the terminology, basically. Okay. So let me start with that. I will share this entire PowerPoint presentation with you in the master class archive. Okay. So let's begin with some basic concepts. Then I will explain what is bottleneck. Then I will explain what is takt time and how to balance the line, how to de-bottleneck the process, and how to double, triple the productivity of any process. Okay. Now let's start it from the first jargon or first terminology, which is called cycle time. What is cycle time? Very simple. Cycle time is time required by that process step or by that machine or by that person to process one unit. Time required to, let's say, for example, let's take a simple process step. Okay. Let's make some pizza here. Okay. So in pizza, what are the process steps? Let's say dough preparation. You prepare the dough, then you add the toppings and the sauces, right? And then you bake the pizza in oven, which is the oven process. And then you cut the pizza and pack the pizza. So now, the moment the order comes, first is dough preparation. Let's say dough preparation takes 2 minutes. For one pizza, if dough preparation takes 2 minutes, that is the cycle time of dough preparation. Are you clear? If topping and sauces takes 3 minutes, that is the cycle time of this process step. If baking takes, let's say, 10 minutes, that's the cycle time. It's cutting and packing takes 2 minutes. That's the cycle time of cutting and packing. Everybody with me? What is cycle time is? To process one unit, how much time are you taking? That is called cycle time. Are you clear with this? Just give me yes. You go to a ATM center. Okay, there is a queue of 5 people. Every person takes 2 minutes to take out the cash. So 2 minutes is a cycle time for that ATM machine. Are you clear with this simple example? Everybody just give me yes, if you have understood the cycle time. Yes, elemental steps. So step by step, every step, to process one unit for every step. Right? So dough preparation 2 minutes, topping 3 minutes, etc. That is called the cycle time of that. So how do we calculate the cycle time? It's very simple. You stand in front of the machine. Let's say you want to check the cycle time of the ATM. So you stand outside of the ATM. The moment the person enters the ATM room, you start the clock. And the moment the person comes out, you stop the clock and note down the reading. Then the next person will go. You start the clock. Once he comes back, you stop the clock. Again, note down the reading. Take the reading 5 times, 10 times, and then take the average. That is the average cycle time. Very basic explanation of this. So take multiple readings and you take the average. So that will give you the idea what is the average cycle time of each and every process step. Okay, this is called cycle time. Now, so this is how to calculate cycle time. This is what I said. All right, you just stand in front of machine, ATM, or a person who is, let's say, caller, okay, in the BPO, a call center. Now you just log in, log out time. You take multiple calls. Let's take last 10 calls. What is the calling time? So that is the cycle time for, so to process one unit, which is one call, that is the average cycle time of that person. Right? Now, let's talk about throughput. What is the throughput? Throughput is nothing but the capacity per over unit period of time. For example, 100 metric ton per month, or 15 million pieces per week, or 100 pizzas per shift. This is called the throughput. It is also called as a capacity. Understand this? Throughput meaning how much you can deliver within that unit period of time. That is called a throughput. Okay. So, for example, as I gave you. So similarly, what is your throughput right now for your process step? Now, one is, so this is applicable for machine wise or person wise or step wise, process wise, or it can be the overall throughput. Are you understanding? So you can define throughput per machine basis. You can define throughput per entire system. All right. Now, can you just type in the chat, what is your current throughput? How much are you producing? If let's say, for example, if let's say you are a hospital, how many patients are you serving per day? That is your throughput. How many, if you are a BPO, how many calls are you serving? How many queries are you serving per shift or per day? So what is your productivity per unit time? The time can be per hour, per shift, per day, per week, per month, per quarter, per year. It depends. Type in the chat box. Exactly, capacity over time. Very nice. Very nicely summarized. Can you type your capacity over time for your own process so that we can connect the dots? I'm giving you the concept. You need to connect the concept with your own process. Type in the chat box. It can be one process. You can take one machine or one process, or you can take the entire unit or entire factory, entire system. Very good. 10 jobs per day, 35 claims per hour. Very nice. Super. So this is your throughput. 1 lakh pieces per week. Super. Amazing. Let's say you are a recruitment company. Then per month, how many recruitments are you doing? That's your throughput. Let's say 50 recruitments per month. That is your throughput. Are you understanding? Yes. So your productivity, your capacity per unit time is called your throughput. 20 assemblies per day. Very nice. Super. So everybody clear about cycle time and throughput? Let's move on to throughput time. What is throughput time? Throughput time, in a simple word, is also called as lead time. Lead time meaning it is also called as turnaround time. Order to delivery, it's turnaround time. Correct? Let's say, for example, if customer gives the order on 0th day, okay, and you deliver the service or the product on 30th day, so 30 days is your throughput time or the lead time or the turnaround time. Okay, so what is your lead time? Type in the chat box. Try to connect with your own process. Are you aware of your lead time? How much time do you take to deliver from orders to delivery on an average? Now, the immediate question is, we have thousands of SKUs. Take the maximum running SKU and take the average. deliver the claims within 24 hours. Yes. Now see, there are two things. One is the service level agreement. What is service level agreement? SLA, which is your commitment towards the customer. And second is, what are you actually delivering? Understand this. So I would rather, mention both. My SLA says 24 hours, but our current average turnaround time or delivery time is 21.2 hours or 21.5 hours. So this is my current throughput time. And our SLA says 24. That's what we are well within our SLA. Okay. Average 15 days, 21 days, 3 months. 3 months once the order is received. So again, different industries, different throughput times. Okay. Only thing is that you need to basically check the throughput time and try to reduce the throughput time, always. Why? Because if you don't do this, your competitor is always doing this, right? And see, very, very simple thing. Customer does not want to wait. And according to Lean, waiting, W, Team Woodka, W is what? Waiting, right? So waiting is a waste itself, right? So customer having the order, customer having the money, right? So does not want to wait. So our role is to reduce the throughput time by using the Lean concept. Yes? Super. Now, everybody's clear about these elements of cycle time, throughput, and throughput time? Just give me yes, so that we can proceed further. Correct? Anyone has any challenge, any doubt? Please let me know in the chat. Now let's move to the fourth point, which is called takt time. Now, takt is a German word which means the conductor's baton. जो orchestra में जो conductor होता है, okay, the person who waves that baton, that wand, right? So that he just follows a rhythm. Okay, so in classical music, it is also called as a tal, right? So a tal is like tha 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 tha. So that beat, if even a single beat is missed, that entire music will not sound good. Okay, that orchestra will not sound good. So this entire harmony is created by this baton, by this person who just waves that baton, waves that wand. Now this is very important. Yes. This will be available in the masterclass archive. Recording will be available. Yeah. Now this, what is the takt time? Takt time meaning, the formula for takt time is this. We will calculate our takt time. Takt time is equal to available time, write this down, divided by customer demand. For example, let's say, for example, I have 8 hours shift. All right, 8-hour shift. So if I multiply 8 hours into 60, which is 60 minutes, so that becomes 480 minutes I have. Okay, out of 480 minutes, the employees take, let's say, 2 breaks. One is for the breakfast, one is for the lunch. Example I'm giving you. Okay, so that reduces down to, let's say, 420 minutes available time. Okay, and let's say I'm working in a pizza shop, and within a shift we receive 420 pizza orders per shift. That means my takt time is 1 minute. What is available time? How much do you have available time to perform, to serve? That is called available time. So 480 is a total time. I deducted 60 minutes, which is 30 minutes or maybe 20 minutes for breakfast and 40 minutes for lunch. So 1 hour deducted. So that becomes 420 minutes. And just for sake of calculation, if on an average 420 customer requirements, the pizzas orders come every shift, So 420 divided by 420 becomes 1 minute. That is called takt time. Everybody clear with takt time? Now I'll explain you what to be done with this takt time. Are you clear with this? Let me know. Just give me yes. Clear hai? If instead of 420, if we only have 210 orders every shift, 210 pizza ka order, so my takt time becomes 2 minutes. Clear? Very simple. Very nice. So, super. Now, can you calculate your takt time? By the way, anybody? Can you calculate your, just give a try. Just give a try. For example, let's say you have, you have a dispensary. Let's say you are a doctor. You have a dispensary and dispensary opens for 4 hours. So 4 hours meaning you have 240 hours. Minutes. So 240 minutes and 240 minutes, you serve, let's say 100 customers, 100 patients. Okay. That means, so 2.4 minutes is your takt time. That means for every customer, you need to serve that customer in 2.4 minutes. If you're a doctor, then only you will be able to, fulfill the demand. Yes. If you are if you are a call center, right? So you have how many minutes call center? Let's say 1 hour call center is applicable. Again, with 60-minute breaks, we have 420 minutes. And during the 420 minutes, we receive around 100 calls. So 100 divided by, so 420 divided by 100 becomes 4.2 minutes. So 4.2 minutes, that means every call must be resolved. That query must be resolved within this 4.2 minutes. Then only we can able to serve those 100 customers. Clear, everybody? Can you just put your takt time in the chat quickly? I've given you multiple options, multiple examples. I've given you pizza example. I've given you hospital example. I've given dispensary example. I've given you call center example. Super. 8 hours. So it is 32 seconds for Ravindraji. Very good. Then it is 3.5 minutes for Sadananji. Very nice. Clear hai? Takt time. Now, what do we do with this takt time? Let's try to understand this. Okay. Let's try to understand this. The takt time concept is linked with something called balancing the process. Okay. Now, let's take the same example. Let me go to my whiteboard and explain the same concept. We'll take the same example of the pizza delivery. Okay. Let's take the same example of pizza delivery. Now, in pizza, okay, let me draw this diagram here. So we had dough preparation, correct? Then we have the topping. And then we have baking. Then we have cut and pack. Okay. So let me draw this. Let's say this is the base. And this is 1 minute. 1 minute, 2 minutes, 3 minutes, 4, 5, 6, 7, 8, 9, and 10. Let's say 10 minutes. Okay. So this is 1, 2, 3, 4. This is in minutes, right? 5, 6, 7, 8, 9, and 10. Now, duff preparation would take 2 minutes. So let me draw this. I'm just drawing the cycle time of each process. Topping would take 3 minutes. Baking would take 10 minutes. So it is the highest cycle time process. And cutting and packing would take 2 minutes again. So these are all cycle time. So let me write down here 2 minutes. This is 3 minutes. This is 10 minutes. and this is 2 minutes. Okay. Now let's calculate the takt time. Let's imagine for 20 minutes is available time and they receive 210 pizza deliveries, pizza orders. Okay. So takt time here is 2 minutes. So what we'll do, we will draw a horizontal line here. So this is the takt time line. Everybody's clear with this? Just give me yes in the chat box. Whatever I've drawn, simple pizza process. Everybody's clear? Everybody just type yes. So cycle time is to process one pizza. How much time each and every process is taking, that is called cycle time. So dough preparation cycle time is 2 minutes. Topping dough is 3 minutes. Baking is 10 minutes. Cutting and packing takes 2 minutes. Now, what is the cycle? What is the throughput time for this? What is the total throughput time for this process? Type in the chat box, everybody. What is the total throughput time for this process? Everybody just type in the chat box quickly. What is the total throughput time for this process? Very nice. Super. So 17, so 2 plus 3 plus 10 plus 2. So totally 17 minutes is the lead time or the throughput. That means if I give you the order, you will take 17 minutes for me to deliver the order. If you are just sitting in the shop, it will take 17 minutes to get a pizza. Okay. If you are ordering from your residence, then delivery time will be added into this. Are you understanding? Delivery time, waiting time, queuing time, all those things will be non-value added, which will, which will be delivering time. You can consider, but these points will be added. Now understand this. For example, after, let's say, I open the shop. Now listen to me very carefully. This can be a little confusing. Just try to focus here. I open the shop. The first customer comes in, gives the order, and I deliver the order in 17 minutes. Very simple calculation. Okay. Instantly, the second customer also comes. Okay. And the third customer also comes immediately, back to back. Now, how much time will it take for me to deliver the second order, third order, fourth order? So this first order in 17 minutes. How much time will it take for the second order? How much time for the third order? How much time for the fourth order, etc.? If customers are coming back to back, think about it. Everybody think about it and give me the answer. So first customer walks in, gives me the order. So 17 minutes is what is required, right? So how much time will it take for the other this thing? Okay, so I got the answers. 10 minutes, 27, 37, 47. Okay, that means the 10 minute, 10, 10, 10 you are adding. So the first delivery will be 17. After that, every delivery will be delivered after 10 minutes. The minimum time required will be the cycle time of your bottleneck process. What is bottleneck? The bottleneck is the process which is having the highest cycle time, which is the slowest process of your system. It's called the bottleneck. So this process is called as the bottleneck process. What is bottleneck? Bottleneck looks like this. Now, if you see the bottle, if I, the neck of the bottle is like this, right? So the flow reduces at this point. So the lowest flow happens at the bottleneck. That's what it's called, the bottleneck process. Bottleneck process is where the process slows down. Okay, it takes a lot of inventory pile up. Are you understanding? Are you getting a point? So this is where exactly it's a maximum time consuming, it's the slowest process of all of them. So that's where you need to basically, what is required here is the focus should be on the bottleneck process. So are you clear with, so after every step, after first delivery, every delivery will take minimum of 10 minutes to come out. Minimum of 10 minutes. Are you clear with this? Just give me yes. Clear hai? ये concept clear हो गया? What is bottleneck? The slowest process. So, and that defines what will be your output. After every 10 minutes you will have. So forget about the first pizza. After every 10 minutes you will get one pizza. After every 10 minutes you will get one pizza. Are you understanding? Yes. Now tell me, if we are getting one pizza after every 10 minutes, you know what is the tact? Tact is 2 minutes. That means customer is demanding one pizza in 2 minutes and you are delivering one pizza in 10 minutes. Are you understanding the gap between these two, the demand and the supply? Just give me yes. The tact is what? Available time divided by customer demand, right? So customer is asking one pizza in 2 minutes, right? But you are delivering one pizza in 10 minutes. And that's where we need to bridge the gap. Okay, so that means a lot of customers will be unserved. They will go back to the other competitor. They will not be happy. They will not be satisfied because your process is too slow, because there is a bottleneck in your process. Now type in the chat box, what is your bottleneck process? Think about your process now. Which is your slowest process? It can be an oven, it can be a furnace, it can be an assembly line, it can be a machine or whatever. What is your slowest process? What is your highest cycle time process? Type in the chat box. Just give the name of the machine, process, step, whatever. OCR. Okay, very good. We may not understand because it's a very specific domain specific thing, but still I want you guys to understand this. Everybody type in the chat box, what is your bottleneck process? Machining required maximum time 66 minutes per job. So 66 minutes, that machining is the bottleneck process for you. Optical char recognition, OCR. Okay, yeah, very good, very good. Final testing machine. Yeah, what is the time? If you know the test average cycle time, just type that in the chat box as well. Draw operation in mechanical power press. Okay, very good. Just type that cycle time. If you know the average cycle time, how much time does it take? So that is your bottleneck process. Now, this bottleneck process has to be focused. You need to focus this bottleneck process. Okay, now understand this. How can we serve 2 minutes? 2 minutes. Okay. Understand this. How can we serve? Now understand this. If we make, let's imagine an imaginary situation. Let's make imaginary situation where dough preparation, topping, baking, and cutting and packing, every process cycle time is 2 minutes. Imagine this. Now we have leveled this. Imagine we have hypothetically leveled all the cycle times. Now all the cycle times are 2, 2, 2, 2, right? So the first pizza will come out in 8 minutes. After that, every pizza will come out in 2 minutes. Yes or no? Everybody, have you understood this? If all cycle times are at 2 minutes, right? So first pizza will take 2 plus 2 plus 2 plus 2, 8 minutes. Okay, let's take it out. But after that, all the pizzas, each and every pizza will come out from the system after every 2 minutes. 2 minutes pizza is out, 2 minutes pizza is out, 2 minutes pizza is out. And this is what is called as line balancing. So first, you calculate the cycle time, you draw the graph, calculate the demand of the customer, calculate the takt time, draw the line of the takt time. Now your role is to basically reduce the what you can say, cycle time to takt time, or match the takt time, or maybe reduce down even further the takt time. Okay. Now let's define this. Okay. Now, for example, how can we reduce the topping from 3 minutes to 2 minutes? What can be done? Let's discuss this out. How can we reduce the topping time from 3 minutes to 2 minutes? What can be done? Now, we all eat pizza. We go to, Pizza Hut or Domino. We see the process, right? Because in the glass, we can see the process, how they make the pizza, correct? Yes, so we can check additional manpower. Very good. Think, do the brainstorming. Just talk about it. Just type in the chat box. Very good. So you can put additional man, okay, and machine. Yeah, maybe we can just automate the topping process, which, ऊपर से, we will make a topping ka machine. Imagine there is a, there is a machine where, let's say, there are 5 types of pizzas. Okay. So I'm just giving you a very raw design. Okay. So for example, so I have toppings kept here. Let's say there are 5-6 types of pizza here. So, and it will be rotating machine, and all the toppings are already kept. Okay. So whatever is the order, you just rotate it, keep that. So toppings are already there, and that they will fall. Okay. They will fall randomly on the pizza. So it can be automated. Are you understanding? So multi-station, you can add the additional manpower. Very good, very good. VA&V analysis, or for the same. So see, for lean, as a lean scientist, I would call you as a lean scientist. Okay, you should never go to the resource addition immediately. Understand this? Have we utilized our current resources fully? That should be our first. Yes, that should be our first focus. Are you understanding? Yeah. Now, yes, reducing the cycle. How do we reduce the cycle time? So if we make 2 people standing for topping, that will make 3 minutes. The cycle time will remain 3 minutes, but in 3 minutes, there will be 2 pizzas will come out. Correct? That means the actual effective cycle time will be 1.5 minutes per pizza. Are you understanding? So by adding resource, but adding resource should be our last resort. Think about it. What can we do? Can we do some VA&V analysis? Correct? As I think Ravindra ji has suggested. Right? So understand cycle time, do some VA&V analysis. How many of you have heard about time and motion study? Time and motion study. How many of you have heard about it? I'll give you a classic example of time and motion study. Okay. Let's say making this assembly of the pen. All right. Now, how the time and motion study works. Let's try to understand this. So I'm the assembly maker. So first I will pick up the pen from the right hand. It will take 1 second. I will pick up the cap from the left hand. It will take another 1 second. Then I will insert another 1 second. Okay. I will rotate and assemble. So this is the 4-step process, will take 4 seconds. It's a cycle time of the pen assembly process. Okay. So first is pick the pen from the right hand, pick the cap from the left hand, insert and rotate and lock. So this is the 4-step process. Now, then we will question, can we do the parallel process instead of picking up the pen from the right hand and the cap? Can we do it simultaneously? That will save 1 second. Are you understanding this? Yes? Or can we make a little different design of the pen? Instead of thread, lock and thread arrangement, can we make a press lock? Okay, press fit, for example. I just insert and press, that's it. And it will lock. So my improved process will be, I pick up pen and a cap, that will be 1 second. I insert and press, that will be 2 seconds. So instead of 4-second activity, I have reduced to 2 seconds. That's how I can do the time and motion study. and reduce the cycle time as well. Are you understanding this? There are various ways we can do that. Are you understanding? So how we have to reduce the cycle time? Just give me yes in the chat box. Innovation. Yes, very good. Correct. Absolutely right. Okay. Now coming back to the baking, which is the oven, right? Now every pizza requires 10 minutes for baking. Let's say this is what is the requirement of the process. Otherwise, it would be unbaked. If you, let's say, take out in 7 minutes, it will be unbaked pizza. So in that case, what will you do? Type in the chat box. So in your oven right now, only one pizza can go. What can you do? Think about it. Very simple. Yeah. So right now you have oven like this, and there is one pizza you can store. Very good. So either you can get a multi-story pizza, what you can say, oven like this, like in the oven, there are multi-story pizza. You can store maybe 5 pizzas, one above another, or you can put additional oven so that the process cycle time of the baking, the effective, see, every pizza will require 10 minutes, right? So you should have at least 10 slots, one above another, right? You can place 5 pizzas at a time. So in 10 minutes, 5 pizzas will come out. That means the effective cycle time will be 2 minutes per pizza for baking. Are you understanding? So either you add 5 ovens of one each, or you add a multi-layered oven. Okay. So that way you have to balance your cycle time. The moment it becomes 2, that's where you can deliver the pizza with the tag time, and you can meet the requirement of the customer. That's how the tag time and line balancing works. Are you clear with this concept? Just give me yes in the chat. Now think about, in your bottleneck, what can be done? Think about it. Let's do this exercise for a couple of minutes. Think about it. You have already listed down your bottleneck right now. Okay. In your bottleneck, what can be done so that the cycle time can be brought down? Think about it. Be a little innovative. Maybe you can take help of ChatGPT. I would encourage you to take help of ChatGPT. Okay. Give the prompt. This is my process. Give the background. This is my bottleneck process. I want to reduce the cycle time. Please give me some suggestion, and ChatGPT give you 10 different suggestions. Exactly. Idli cooker, multiple idli, the same similar kind of example. Like we are adding the multi-layer baking of the pizza. Same. Very good. Preparation tray of loading baking, it can reduce further cycle. Exactly. Exactly. So what we can do is first at least match with the cycle time. Right now there is a gap between 10 minutes and 2 minutes. Now we are matching with the tag time, and even there is a further scope for improvement. Of course, we can do that always. Very good. Think about your bottleneck. What can be done? Just think about a couple of minutes and give me at least a couple of suggestions. In your case, what can be done to reduce the cycle time? See, this is where the practical application comes into picture. We don't want any just only theoretical concepts to be discussed here. These are very practical, super practical. And that's how the lean works. You can see, after you master the concept, now you can walk into any shop, walk into any office, or walk into any factory and tell them that this is your bottleneck, and I can, reduce your bottleneck and double your productivity. Okay. Yes. Optimize arrangement. Okay, correct. Give jig and templates to be skill and zero defect. Very good. Super. So that can reduce your cycle time and fast track your process. Very good. So, bottleneck has to be kept always running. Understand this. Bottleneck downtime is disastrous. So you cannot keep the bottleneck stopped. So bottleneck, you need to make sure it should not be breakdown. It should be continuously running. Clear, everybody? Just give me yes in the chat box. Yahan tak clear hai sabko? Just give me a quick yes. I'll show you a quick 1 minute video about this. Okay. Understand operators pain, automate, non-bottleneck. Very good. Fantastic. Let me share a video with you. Just a second. This is a video of a restaurant. It's a Visa MasterCard. Visa ka ad hai ye. Just look at the Visa card where people are coming in the restaurant and they are coming like, for example, 1 second, okay, per person. Even not 1 second, even less than that. Okay, 1 second per person. Let's consider 1 second per person. The people are coming in the restaurant, and how they have matched the entire process. They have balanced the entire process, and the person who is giving the payment in the cash, it disrupts the entire cycle. Just watch this video and then we will take it forward. Just listen to this. Now, can you see here? The clock is just showing the takt time, and are you really serving your customer within takt time? Just see this.
The Visa check card. Because money shouldn't slow you down. Life takes faster money. Life takes Visa.
Super. Understood this? Yeah. Just give me a quick yes in the chat box. Amazing, amazing. Very good. Now let's move forward to capacity multiplication. Okay. So we have seen debottlenecking, we have seen the takt time, we have seen the jargons of lean, we have seen the line balancing, etc. with some practical examples. Okay. Let's see how do we increase the capacity. Now, this is something very interesting. If you can master this art, okay, you can literally double the productivity of some factory in a very limited time. You need to know where you should focus, and your focus should be always be on the bottleneck. Okay. Now, for example, let's take the example of this. There is a company, okay, and they are producing 400 pieces per day. Let's try to understand this. There is a process which is producing 400 pieces per day. It can be pizza, it can be anything. Okay, per day they are producing 400 pieces. All right, that's their throughput or the line capacity, which we have already studied this. Okay. Now, if you break down that process 1, 2, 3, 4, 5, right? Now, the management feels that there is a huge requirement from the market. Now we have to double our capacity. Correct? So what are the options we are having right now? We need to double the capacity. From 400, we need to go to 800. What can be done? Type in the chat box. See, they're very simple concept, but very powerful, okay? And absolutely practical. You can do this. Yeah. Tell me. What can we do to make it 800? Because the marketing department, the sales department is saying that our throughput capacity is poor. Otherwise, we will definitely bring more orders. But we can't deliver it. So the CEO is in dilemma. What can be done? Yeah, double the line arrangement. Very good. So we can put a parallel line, increase the work line. Fantastic. So let's put the parallel process in place so that we can double. So from 400, we can make it to 800, right? Very nice. That's the generic approach, guys. Understand this. But as a lean scientist, our process, exactly. So our question should be, can we only take out 400? Okay. Yes. Yeah. See, the first thing is, ask the question, is the capacity. Are we optimally utilizing the capacity? That's the first thing. Okay. Yes, here we go. Now you are hitting the bullet, hitting the bullseye right now. Now we need to identify what is the bottleneck process. Okay, so here what we will do it. So obviously other people who don't understand Lean and Six Sigma, they will simply say that okay, we'll put a parallel process. Okay, we'll put additional investment in the double the capacity. That will have a huge capital expenditure, right? But as a Lean Six Sigma scientist, what we need to do first understand the cycle, the capacity of each and every process. So here you can see process 1 has 1200, process 2 400, 4000, 1600, process 4 has got 400, and process 5 has got 800. Why they are only producing 400? Because they have a bottleneck process of process 4 which can only produce 400. Understand this? Are you understanding this? Now that means we don't need the entire 5-step process. Can we put additional process 4 only? That means 400 plus 400 becomes 800 directly. How many of you got it? Just type yes in the chat box. So instead of adding the entire parallel line and investing huge in the capital expenditure, first check what is the process by process capacity. Okay, what is the bottleneck process? And just debottleneck that step. That's it. The moment we debottleneck that process, then you can double the capacity. Just by adding one, let's say, machine or one process step of process number 4, you can double the capacity. You don't have to purchase the entire line. Understand it. This is what is as a lean consultant you to suggest to the management. So today's learning is to double your productivity, focus on the bottleneck and debottleneck that. How many of you got the bulb on moment with this point? Just give me BO in the chat box. BO meaning bulb on. Now I have given you a formula. You can walk in any business, literally any business, identify the constraint or the bottleneck and work on the bottleneck and increase the productivity, increase the turnover, increase the profit margin. How many of you got it? Have you understood the power of the methods what we are learning here? These are not only theoretical concepts, these are practical concepts. Super practical concepts, which we day in, day out implement in our client's place. Correct? Bulb on moments, absolutely, that's what they have done. Instead of 400. Now, another thing is, these are the process. If I increase the process of process number 5, and from 800, earlier it was 800, I increase the productivity by 50% improvement. Now we are producing 1200. But will it make any difference to the final output? If I work on process number 5, will it work on the final output? Will it impact on the final output? Just give me yes or no in the chat box. Will it impact? No, right? It will not impact. If I work on process number 1, will it impact? It will not impact. Only if I work on process number 4. Okay. Now understand this. If I increase process number 4 capacity, okay, imagine, let's say, for example, let's go back to the original step. Now imagine if I put 3 machines here, 3 parallel machines. Now my capacity has become 1200 and suddenly process 5 becomes the bottleneck now. Have you understood? Just give me yes in the chat box. Let's say if I add 2 additional processes, now my process 4 can deliver 1200, right? 400 plus 400, 1200. Now I have 400, 1200, 4000, 1600, 1200 and 800. Now 800 has become my new bottleneck now. Are you understanding? Now, if I double my process 5 here, now my process 5 can deliver 1600. Now again, process number 4 and process number 1 will become bottleneck. How many of you got this? Just give me a second. So the bottleneck will keep on shifting. Bottleneck will keep on shifting. But in the process, earlier you were making 400, then you started making 800, then you started making 1200, etc. Have you understood? You have increased your capacity multifold. And this is the theory of constraint. This is how the theory of TOC works. You have to work on the constraint and basically expand that. Okay. And the constraint shifts, the bottleneck shifts to the next. Okay. Now, so here we need to basically add another process and process 4, and you will get additional double capacity here. Okay. Another part which is there, which you can do is reduce the, what you can say, reduce the inventory. Okay, WIP. For example, there is a law called Little's law. How many of you have heard about Little's law? Just type yes in the chat box. Little's law, किसने सुना है? There is Professor Little and Professor Little. So Professor Little is from MIT, Massachusetts Institute of Technology. According to him, the lead time or the throughput time basically is directly proportionate to your WIP, which is work in progress inventory, basically. In bracket, I will say inventory. Okay. And inversely proportionate to the processing time. Okay, the processing time. I'll explain you this with a simple example, which I always give in our hackathon, etc. Let's say you are standing in a queue in front of ATM. Okay, let me draw this ATM. Let's say there is an ATM machine. This is ATM. And there are 5 people in the room, in the queue right now. And you are the 6th person. This is you. Okay. And everybody takes 5 minutes to take out the cash. Okay. Are you understanding? Everybody is taking 5 minutes. So let's say WIP is 6 people. So lead time is directly proportional to WIP. So tell me, how much time will you take to take out the cash? Type in the chat box. Every person cycle time is 5 minutes. You are the 6th person. How much time will it take for you? Type in the chat box. Everybody. Very simple calculation. Very simple. So 6 multiplied by 5 is 30 minutes. Clear, everybody? 30 minutes you will take out the cash. It will take the total 30 minutes. Correct? Yes. Out of which 25 minutes will be waiting time, non-value added time, and 5 minutes will be value added time, which is cash, taking the cash. Okay. Now, how do you reduce this lead time from 30 minutes? Let's say the first thing is work on the WIP. In this case, our WIP is number of people in the queue. So what Professor Little suggests, let's reduce the WIP. Now, the second option is, let's say second scenario, instead of 5 people, now there are only 2 people in the queue. So let me remove the 3 people here. There are only 2 people before you and you are the 3rd person. Okay. Now tell me what will be the lead time. So I have just reduced the WIP. What will be the lead time now? Type in the chat box. So it is 15 minutes. Can you see here the difference? So your lead time has reduced the moment you reduce the WIP. Okay. Now it is inversely proportionate to the processing time as well. Processing time is 5 minutes, which is cycle time. If I reduce cycle time, understand this. From 2 minutes, let's say I increase the capacity of the machine, or automate some parts, or increase the what you can say internet speed. Okay, it was earlier working on 3G. Now I am working on 5G. Okay, so now the cycle time is 2 minutes. With two people in the queue and you are the third person, with 2 minutes cycle time, how much time will it take? Type in chat box. Now it will take only 6 minutes. Are you understanding? So by working on the cycle time or the processing time and the WIP, you can reduce the lead time drastically. Are you clear? So WIP decreases your velocity or the flow. Okay, this is the concept I just wanted to drive. So you can check this out. Yeah. Apart from that, you can work on the team wood, how you can increase the capacity, identify transportation, inventory, motion, overproduction or processing, remove all the team wood, which is NVA, non-value added. This is one way of doing it, looking at it. Now, how you can do that? Increase the capacity of the bottleneck, as we have already seen that. Let's take the same example of the pizza making process. So, make your bottleneck handle more work. How you can do that? How you can do that? Make additional manpower or machines, give additional shift, okay, to the bottleneck. Let's say, for example, other things are working. In some cases, this happens, okay? Other operations only work for one shift, but the bottleneck operations work for two shifts. This also happens because the bottleneck you have to run more because that defines your ultimate throughput, right? Then you need to reduce the downtime and the setup time of the bottleneck process. Okay, improve your preventive maintenance. So example in the pizza shop is, if the oven is the bottleneck, put additional oven or bake multiple pizzas at once. That's what we have already discussed, right? So this is one way of looking at it. Apart from that, eliminate non-value added activities. You can make a value stream map, identify the inventories and all the team wood, and you can do 5S, SMED technique, single minute exchange of die, or the some small Kaizen automation stuff where you can reduce the lead time and the cycle times of the processes. Okay. For example, if in the pizza shop, if the chef is spending time in searching ingredients, okay, so you can easily put 5S in place and organize the workstation so that the time can be saved. Okay, and so that the pizza making can become faster. Then load balancing, which we have already seen, how you can balance the load as well, right? So balance the work across the resources. If somebody is having the spare time, you can use that resource over there. Shift some tasks to non-bottleneck areas. That's what I said. Cross-train employees. So employees can be cross-trained. Everybody can do all the work, right? Use flexible machines, multi-skill labor. So if the pizza topping is slow, train another worker to help the topping person during the rush hours. Okay. So if let's say dough preparation is easier or it is automated, then that person can help the topping person during the rush hours. Okay. Then improve the quality to reduce the work. For example, use the Pokayoke system, mistake proofing, or root cause analysis, fishbone analysis, standardize the work. Okay. For example, if the pizzas are undercooked or underbaked, so there will be customer complaint and you have to redo that, right? Rework, correct? So just to reduce those kinds of quality defects, you need to work on Pokayoke, root cause analysis, fishbone, etc. Okay. So these are various strategies I believe you can implement and focus on the bottleneck and de-bottleneck your process. The moment you focus on the bottleneck process and do these activities, you can literally double your productivity, double, triple, and even multifold your productivity, and give the results to your clients and your company as well. Okay, clear with these concepts? Yes. Did you find this interesting? Just give me yes in the chat box. Best practices video. Yes, exactly. Standard work practices and train the people. Absolutely. Did you find this session interesting? Conceptually as well as practically as well. You can see how practically you can use this. Just give me yes in the chat box. Super interesting. Very much. Very good. Very good. Super. Thank you very much. Thank you very much. Okay. Any question you have, you can just put it in the chat box. The question could be related to the today's topic, or it could be something what you are studying. There, if you have any question, query, you can put it in the chat box, or anytime you can connect us on our mentor number, and we will be more than happy to support you, serve you. All right. So I think that's it from my side. The recording will be available in the masterclass archive. Okay, just check out the recording and understand how this function. I will keep the PowerPoint presentation also downloadable, so you can download this in the PDF format. Okay, done. So thank you very much. Tomorrow we have a yellow belt session. If you want to refer any of your friends and get the referral bonus of 4,000 per referral, right? If they upgrade, then you get a 4,000 rupee referral bonus. Then please do that. Tomorrow we have the live session. If you want more information, just check out with the mentors. Okay. Thank you very much for joining. This is Dinesh Patel signing off.